After chemicals shift, the next thing we have to look at is spin-spin coupling. Now this is a big fancy term for essentially splitting of peaks, and this is what we can see in our unknown spectra. Now if you look at your NMR visual guide that's up on Blackboard, well, let's just go through this. Hydrogen nuclei themselves possess a small magnetic field. We know that from the proton, and can influence the signal seen for hydrogens on neighbouring carbon atoms. So what's next to them, or next door to them, as I always say, can influence it. This is known as spin-spin coupling. The number of signals the original signal is split into is equal to the number of hydrogens on the neighbouring carbon atoms plus 1. So that's a good thing there, plus 1, according to the pattern shown on the left. So here we have a singlet, doublet, triplet, quartet, quintet, sextet, septet, octet, nonet. Now you don't really see anything down here much. The area underneath the peaks indicates the number of hydrogen atoms responsible for each signal. So that's the next thing coming up. But just look at it. The signal is split into is equal to the number of hydrogens on the neighbouring carbon atoms plus 1. So that's the key thing there. So if we look then at what I've written here. So hydrogens in the one environment are affected by hydrogens in the neighbouring environment. So if you're next to a CH2, so 2, the peak splits into 3. So 2 plus 1, 3. So we refer that to as a triplet. If your hydrogens are next to a CH3, that peak splits into 4. 3 plus 1, 4. That's referred to as a quartet. If it's next to a CH, well, that's only 1, peak splits into 2, because 1 plus 1 equals 2, and that's called a doublet. And that's what we see a lot in our unknown spectra. Now sometimes these can look very squashed, and you'll see in our unknown spectra they maximize it, they hone in on them, and they make it clearer to see. But that's how we can tell which environment is directly attached to the next environment. And that's why NMR spectroscopy is so good at identifying the molecular structures.